Hello and welcome. Thank you for inviting me all the way to Shanghai. I'm from Amsterdam, the Netherlands, so it was quite a trip. Yeah, I will start my talk by compiling the presentation. Let's use Cargo Clean. Cargo is the build tool for Rust. It's like NPM in a way. With Cargo Clean, we now have a clean build. Then I'm going to compile Makepad Studio. This is our IDE that we're working on. And as you can see, it doesn't take long, 9.2 seconds, which is great for every dependency. And yeah, let's make some slides. Okay, so here we have a slide. Hello, GOSIM. And welcome to my talk. I'm gonna make my slides on the go now. Talk. It's gonna be really tedious. Nah, I'm kidding. Let's just start the slides separately. Let's see my slides, and if I can full screen this. I can switch, that is nice. So, welcome to my talk. Live application building with Makepad. A very long time ago, I was working on Cloud9 IDE. It was my startup at the time. It's about a decade ago, 10 years ago. And we were also building ACE, a code editor built with HTML. And we were using HTML as the IDE UI. So everything was HTML. Everything was divs and CSS. And integrating design and code was very hard. We had a design team working on our UI and on our branding. And they had sometimes 6 months of designs ready that the developers couldn't implement in time. Beyond that, HTML was also extremely limiting to building a code editor. It was very slow, so we couldn't really innovate much, right? You can only show text, and at best you can scroll fast, especially 10 years ago. We could barely be competitive with Sublime at the time. And it was just too hard to control, because it works in one browser and it doesn't in another, and it's very tedious if you're trying to build an application that is not a simple web page. So I decided to start over, completely from scratch, no more HTML, but I still wanted to use JavaScript, because I was a JavaScript programmer at the time. I didn't program Rust. Rust didn't even exist. But I wanted to use WebGL. WebGL is a very low-level graphics API that runs in the browser, and you could write shaders for it. And I used to be a graphics programmer back in the 2000 era, where I wrote C++, where I wrote DirectX and OpenGL. But that was long before the GPUs were programmable. The GPUs were fixed pipeline, they called it at the time. So when I came back to graphics programming around 2013, there was this new thing called shaders, where you write little pieces of code that run on your GPU. And I thought that was magical. I thought there was possibility there to start styling your UI with shaders instead of using CSS gradients. So I tried, and I tried again and again. I started over 5 times with this project between 2013 and 2018. And I kept failing. I have a final result I could show you. Just quickly, could be fun to have a look. Let's see. I have to actually restart my IDE for that, hold on, Makepad.js. So yeah, this was Makepad.js. This was the JavaScript version of what is now Makepad in Rust. It was a complete live coding IDE in the browser for JavaScript, using shader functions written in JavaScript as well. So I wrote a transpiler that took JavaScript code and turned it into shaders. And this was essentially my prototype for what I'm going to show you in a bit. This is my prototype. This is where I figured out the model of how I wanted shaders to be programmable inside the UI. where you have a very direct path between the CPU and the GPU, so that the overhead of customizing these GPU programs for UI becomes so minimal that it's actually doable. Yeah, here we can, for instance, let's see, we can type GOSIM. It's still, everything is live. It has an AST editor, so here's the code editor, live reformatting as you type. It's very neat. It has a lot of neat ideas. The only problem is it starts crashing after programming for half an hour. So if you type in this editor for half an hour, Chrome, at least at the time in 2018, would just crash on you. And I couldn't figure out why. It's probably some garbage collector bug or something deep down that only triggered after half an hour. And I was not a Chrome kernel or Chrome core developer, right? So I couldn't really fix it. Besides, I've had experience with filing a bug for Chrome and it taking 3.5 years before it got ignored entirely. So I didn't feel very hopeful that this particular kind of use case, which is live coding JavaScript in a browser, was actually going to get much attention from the team. So yeah, I had to give up. And I don't give up very easily, but in this case I gave up. I have to open my slides again. Let's see, slides. So that was the final result. It was kind of cute, you know, but as what is the case with web, and at the time I always say that, you know, that's cute, but yeah, that's about it. You don't get a result, you don't get a working product. So the good part of the JavaScript IDE was that you could do live coding, right? You just saw I could type in there, I could do things, and it updated the application live. But the bad parts are it's too slow. JavaScript, even if you really try, I did on-the-fly code generation, I did all these tricks to make it faster, it still wasn't fast enough. A friend of mine in game development, when I finished this IDE, he was like, wow, that's really cool. But what are you going to build with it? Because you can't get data into the browser. Browsers are notoriously difficult to get large amounts of data in. They don't access a lot of memory very easily. To top it all off, once somebody makes something very complex, the browser would crash. So now what, right? 5 years of my life gone. I figured this was, you know, not a very fun thing because my entire idea of building a live coding IDE did not have a path. I could not do it. So at the time, Eddie, my co-founder, you will see him walking around this conference as well, worked at Mozilla, and he was involved with the Rust space because the Rust language came from Mozilla. So he introduced me to Rust. I was like, okay, maybe this language can be what you need because it also compiles to WebAssembly. Because one of the main things I always wanted was my applications, at least the applications, to run in a browser. Because it's great. Browsers are great. If you want to send somebody a link of a working application, there is no other platform that is as easy as a web browser. So the distribution model is unrivaled. The execution model, not as much. So, yeah, we came up with the idea of executing this idea of a live coding IDE, Makepad, the name has stayed the same, and turn it into a startup. And this is what we're doing right now. So Rust is a compiled language, which is great and not great. It's great because you get to use LLVM. LLVM is a low-level virtual machine. That's what it means. And it's essentially a compiler, a modular compiler system. So what they've done is they've separated the compiler into a front-end modules and back-end modules. The back-end modules generate the machine code for different CPUs, and the front ends parse different languages and do all the different things that languages need to have done, like the syntax, the type checking, that kind of stuff. What this allowed to happen is that all of a sudden, a lot of languages could share the same compiler optimizations, right? The backend and the optimizers for C++ could be used for a new language like Rust. So when they started making Rust on top of LLVM, they did not have to implement all of those CPU backends that LLVM brings. So when you see Rust's cross-platform abilities to target all these different CPUs, that is because they're using LLVM. It's an original project, I think, started at Apple. But this is a huge strength. If you come from JavaScript, JavaScript is a high-level language with a VM that tries to be fast, but never really succeeds at being fast. So once you have a new language that is compiled with LLVM, all of a sudden you get decades of PhDs that make your code fast in ways that I don't understand anyway. So finally, we have performance again. Here's what performance means. Let's see if... It is running very smoothly on my computer, but for some reason, projectors always have buffers in between, so that it looks a bit janky. But if you want to see it running at 120 Hertz, so you should come see it on my laptop. But here I'm using 10 cores, SIMD, single instruction, multiple data, it just flies. So these slides are a Makepad application. They're essentially just a widget that I made, so I could do my slides in. However, now that we're using Rust, what happened to live coding, right? Because Rust is a compiled language. JavaScript, you can say, hey, here's a new function, here's a new piece of JavaScript, run it, please. I mean, theoretically, you could say that, except that Chrome would crash if you seriously thought that was an option. But with Rust, I have no option, right? I have to compile a new application. So how do we solve this? And for Makepad, it is good to also reiterate our goals. Like, we want to make programming fun. So if we choose Rust, we have to make programming Rust fun, which is actually quite a challenge, because Rust is a little bit of a mean language, and it's also a great language. Like, the errors are brilliant, but the coding style that it forces on you is rather restrictive. So it's a mixed bag. And as I said in the beginning, when I was doing HTML, one of the biggest bottlenecks we had was integrating the workflow of a design team or a designer in application development, right? So if you do HTML, I think a lot of people, especially if they're a little older, know that the designer used to make a Photoshop file and then hand it to the developer, who would then hand convert it to an HTML page. I always call this human JPEG compression. That is not optimal, right? Because if you have an application, you have over the life cycle of the application, you have lots of design changes, lots of insights, lots of tweaks, lots of A/B tests, where you want the designer to feel a part of the team. And also when he changes, or he or she, or whoever changes the design, it should be updated very quickly, ideally in real time. And we still want live coding as much as possible. So for Makepad, we came up with a solution, which is to make a domain-specific language. HTML is a domain-specific language for, well, a web page for structured tags with text in them. So Makepad has essentially its own HTML. It has a form of it, and I will explain that right now. I'm going to continue the presentation now in Makepad Studio. If you want to play with Makepad Studio, you can clone the GitHub repo, and you can run it like this. So yeah, if you have access and want to play, whilst I'm talking about it, you can do so here. So I want to look at a Makepad app. So what does this look like? What does this look like? So let's see. Yeah, let's start with a simple one. See if I can make it any bigger. Open it. So yeah, this is Makepad Studio. I'll show the UI a little bit. I think the file tree is pretty small. I should have made that font bigger as well. But it's not that important. Let's see, simple app. So if you clone the GitHub repo for the Makepad project, this is essentially a completely self-contained repository. So it contains Studio, it contains the examples, and it contains almost all of the dependencies. So the reason Makepad compiles so fast is because we really try to limit our dependency use. A common used argument against Rust. Could I have a bottle of water, please? A commonly used argument against Rust is that it compiles very slowly, which is not really true. It is just that people have grown accustomed to piling on a lot of dependencies. So this is why the repo is completely self-contained, or mostly. We have the libraries, we have the examples here, and the different main components. So we have Makepad Platform, which is the platform abstraction, that's the windowing and the GPU. We have Makepad Draw, which contains the basic draw shaders. I'll go over them in this talk. And we have a widget library, which is growing, but definitely not complete. We have a lot of work to do on mobile widgets, on just general completeness, like we don't have a combo box right now, which is a combination of a drop-down and an edit control, these kinds of basic things. And here, the idea that we're trying to do with Makepad is that applications are, let's see, oh, that was my slides. Applications are in a compiled state. So you essentially turn on the build, right? So the application stays running and it recompiles or updates live. So here we have the click to count button. I can just write hello world in there. And as you can see, this is real time, right? The updating is 60 frames a second or whatever frames a second. However, if I then go to the Rust code here, this is a Rust code, and I change it count, hold on, yeah. If I change the Rust code, you see that it needs to recompile. The window grays out a little bit, and then it recompiles. So that is the solution we came up with to how do you live code Rust, which is take it as far as you can go in making it as least shitty as possible, which means integrating the application into the IDE, as you see here, right? We have a complete run view of the application in the IDE. It's not a separate window. This is actually quite a difficult technical challenge, and in the deep dives later today, I will go into how this works, if we have time, of course. But I wanted to go over how does a Makepad app look like? What does a Makepad app look like? So, as I said, we have our own HTML. We have a domain-specific language that is designed for designing a UI with shaders. So in Rust, you have macros, and macros you call with an exclamation mark. Or not all macros, but this macro that you call like a function, you call with an exclamation mark. So whenever you see something with an exclamation mark in Rust, they're kind of dragons because you have no idea what actually is generated in that place, which is, it's good and it's bad. Macros are good and bad because it's great because you can actually construct a lot of complicated things in Rust with macros, and it's bad because whenever somebody sees a macro, they instantly don't know what is going on anymore. But in this case, we try to keep the macro very, very specific. So you see live design here at the top, then it imports the widget library, essentially, the base widgets, and it imports the theme. And in this case, it's using the dark desktop theme. And then we get to the application structure. Here you see essentially what is a Makepad UI class. It is an inheritance. So you say app inherits from the Rust object app. So if you see two curly brackets here, it means that there's a type connection between, this is Rust code again, right? So Here, between here and here is our language, and beyond that, everything is just normal Rust. So your application has a struct that holds all the state of the application and a reference to the UI tree. If you use it as the base class of this object, everything that is shown inside that object will be used as the values for that class. It's essentially a property bag. It's a bag of key value pairs that is loaded into the Rust struct. That's essentially how you can see the DSL. There's no code in the DSL except for shaders, but shaders are a little bit like functional programming. They can only output a color, and they can only have input values. They cannot output state. So they're essentially functional little programs in there, but there's no code. It's not Turing complete. It's not a Turing complete language. It's just key values. So if you see UI is window, then it means take the property bag called window, copy it onto the UI, and override these properties. That's all that it says. So when you see drawBG, it means override the properties that are in that object with the properties that are in this child object. So I think I can also return a color. That's a bit bright. Let's see. So here I show a little bit that this shader program that is running on the GPU inside of the UI styles can be live coded, right? Because I don't have to run this through the Rust compiler. This can go to essentially an online compiler that is present in the video driver of your computer. So depending on which backend you use, DirectX or OpenGL or WebGL, this can be updated live, which is really cool. I don't know if anyone has heard of ShaderToy before, but essentially this is ShaderToy. This is ShaderToy for UI. But you could do all of ShaderToy in here as well, which is just a fun thing I intend to do with it. So inside window, this essentially opens a window. We have a body where you can put the content. So in this case, we say the body is a view. The base of Makepad's UI system in the dynamic sense is built out of views. So I think the simplest analogy to a view is a div. This is our div. Essentially, it's just a rectangle on the screen that can have child rectangles or child components. A dynamic child component. So we say flow direction down. That means that every child is laid out vertically, which is, I think, similar to a V-box, right? You stack child components vertically, so it flows down. You can also flow right or overlay. And give them a spacing of 20, right? Now we space them further apart. And we align them center. And an aligned center in this case means that we align them with a floating point value. So 0 is to the left, 0.5 is in the middle, and 1.0 is to the right. So this gives you a little bit more alignment options than using align left or align right. You can use a fraction to align it. And yeah, this is a text input. I don't know what the text input is doing there. I don't think it does anything, except for that we can edit it here. And here we have a button. This is a very simple button. It is essentially our basic unstyled button. And then we have a label. A label is just a text field. It should be able to format things, also multi-line. So yeah, this is just a text field. As you can see, if you do this, the application actually breaks. So it has to restart and recompile because it can't parse. If you break the parser of the main application, it has to restart. So yeah, so this is the DSL side, right? It looks very similar to HTML. I also tried to use tags. So this is very, very, very similar to using web components, right? It's just custom tags. And then we come to the Rust side of things. This is an application. So in Rust, you have a function main, right? This is like your main function, just like in C. Except because Makepad applications run on a lot of devices, which I'll show later in this presentation. A lot of these devices don't have a function main, right? On WebAssembly, I don't have a function main. On Android, I don't have a function main. So that means that I had to make a macro to allow you to write it once and run on all these different platforms. So that's what this does. If you're looking for a function main in this application, it's not there. This is generated by this macro. And then we have the struct with the UI and the state. In this case, it's just a counter. It is very, very simple. We don't use very complicated state management systems here. It's just like a JavaScript object with a counter property that you can mutate. Hold on. Okay, I have to check the time. So in terms of the life cycle, we have something called live hook. That is a hook into the live system that allows you to set callback points. Like, hey, could you let me know when you have updated yourself with the DSL, with the UI structure? Hey, could you, before you do that, after you do that, or when some value changes that you do with live hook. And, well, we don't, this was supposed to be a demo for async network requests. That is something that we're working on. And then we have the core event loop of a Makepad application. This is different from I would say, many application models, like many JavaScript application models, use things like on-click handlers, or they use closures. So effectively, you set a function that gets called when something happens, right? The problem with that is that closures are in need of state that is around themselves, right? They need to access variables that are closed over, as it is called. And Rust's memory model, the borrow checker, does not really like that, because as soon as you have a closure that closes over a variable, you kind of don't know when you can free the memory for that variable anymore, because you don't know when that closure is going to be called. Maybe it'll never be called, maybe it'll be called on click. So in languages like JavaScript, the on-click function handler actually starts to collect references to the variables that it can access, and the garbage collector then cleans that up for you, right? So this is why a garbage collector is a very convenient way of making an on-click handler, because you can access these values. But in Rust, you can't. In Rust, you have to put ref cells around them, arcs or RCs around your data to allow safe access, right? You need to start ref counting your data to be able to access it from these closures. So with Makepad, we try to make a model that does not need to use closures. And for that is essentially this function, the handle event function on app, is a very important one. This is this is where all of the events in the application come in. So you have an event, and that event has, in this case, a draw function, like, hey, could you draw the UI? And because I don't do anything else here, I just ask for this UI here, this window, just draw yourself. So here, widget draw all, that means draw all items in this widget. And the reason is that we also have an interruptible draw flow, but I'll show that in a bit. And then we ask the UI, like, hey, do you have any actions happening? So for instance, a click, the button emits a button clicked action, right? But it's a generic type, so it's a trait. So you can plug all of the actions that are coming out of your UI into a single actions vector that's using those traits. I'm not going to go deep into explaining all of it, because that's more like a Rust course. But yeah, the point is you can then query the UI I think the most important way we do UI in Rust is by querying the structure and then checking if something happened to that item. And this is very, very fast because it's an optimized query. It caches the query, so that means that this check runs in very, very short amount of time. So if you have a very complicated UI, you probably spend like a millisecond in the event flow or something like that, which is perfectly acceptable. So for this one, it's like it's completely nothing. But you poll. It's a polling architecture. So you poll the event. In this case, if this button 1, was clicked, then we just mutate the state, and we set the label, in this case, to the new value. And there it is. It's very, very simple. It's also kind of old school. It's not, it doesn't use, in this example, it doesn't use like a functional flow. You're literally changing the value in the widget. But we do have that as well. We have different models in the UI system. Okay, so let's see where I am. Well, this was the synthesizer that I wanted to show. I don't know if I've got audio. Do I have audio? I should have audio.
Line.
Yeah, I should have it. You should hear something now on the.
Okay, I'll go ahead and check it.
Okay, we'll get back to it when we can hear it. So, yeah, the news feed, right? So this was a very simple example, but now let's look at a little bit more complicated example. Because applications usually have to have a lot of data represented in them, right? Applications are usually not a button. They're actually a lot of applications nowadays are a form of a scroller of content. In this case, yeah, it's a sort of a mobile application that is showing content, and it has some button interaction. So let's go to the news feed. Yeah, as you can see, we get a lot more code now in our DSL, right? In our HTML. It's not just a simple window anymore, but you start to see the use of components, right? So this is, by the way, the feature that I could never have in HTML that I can now have, which is animated code folding. So I can get a quick overview over what we're looking at. But what you see here is essentially the component outline of the application. We have a button, we have a header, we have a menu, we have a post menu, we have posts, post image. This is, for instance, the contents of the post, right? It has an image profile. It has a little shader here. Let's see what that does. Let's see. Right, this is the little circle for the profile image. And then there's your content, right? This is the little label that is in the UI. And yeah, so a designer, Sebastian, my other co-founder, actually wrote all this code, this design, and then I didn't have to do anything anymore except make the widgets and make the logic to complete this application. And what I currently cannot show you, what we're working on, is that this structure, just like I can live edit the values that show up in the application, this application is going to get a design tool that looks like Figma, sort of, or other Illustrator or something like that, that is going to directly manipulate this source code. So where you see that I change values here, the visual design tool, when you drag a button or when you change a value, will also edit the source code. This is the thing that we're building next. Yeah, I thought where we are now with the IDE is already a pretty good demo. So yeah, so we go to the news feed. Here we have the news feed is a portal list. It's a name I thought long and hard about, but a portal list is essentially a portal view onto your data. That means that when I'm scrolling like this, there are no items above and items below what you're seeing here. Essentially, it's a viewport. It's a virtual viewport. It used to be in UI called virtual viewport rendering, where a widget just asks for the data that it can see and only renders that data. And if you do widgets that way, you can do this widget. I think the CPU time and the GPU time of this thing is almost zero, like a millisecond or less. However, then you need to write the draw loop in a slightly different way. Here, just like in the last example, we saw that we have a draw event, but instead of saying draw all, we ask it for a widget that we need to draw ourselves, right? When you have a widget like a list in a UI tree, how do you give it data? How do you give it state? How do you tell it what data it has, right? So the old school UI frameworks were very basic. You essentially called, just like we did set label, you did set list or set item. You essentially used it as a mutable data store for the items in your list, which is a terrible idea because that means that you need to write a synchronizer. You need to write a synchronizer between your data and the state in the widget, right? It's much easier if the widget, when it needs to draw itself, can ask you for the data. So that's what this is. The widget asking you for the visible items. So you say we have 1,000 items in our list. It is useful to give it a range because otherwise the scroll bar has no idea what to do. And then you just ask it for the next visible item ID. So in this case, the visible item IDs are going between 0 and 1,000. And then in this case, I don't even have actual data. What I do is I just generate some data based on the ID. So I'm not actually scrolling data. This is a procedural scroll view. And the way that works is, first of all, I decide on a template. So if you see here, the portal list has 4 templates inside. It has the space at the top of the list, then it has a post with an image, and something at the bottom of the list. I don't think we use those, but yeah, we only use the top one. So it picks a template, and then it tells the list, hey, could you instantiate this template for me with this ID? Right? So the difference between this and how you would do this in React is in React, you would write code into your template. You would take a template and you would write values into the code. So when you see here post or post image, in React, you would expect that you would be able to write, in that case, JavaScript, inside the template directly. But because we're preparing this tool to be a complete visual designer, I cannot do that. Because this structure, this entire live structure, is the domain of the visual design tool. So the moment I put code in there, the visual design tool is going to fall apart. It doesn't work anymore. I mean, barring some experimental things that try to do it, but nobody has actually succeeded at that. So Makepad is also an attempt at sort of accepting certain things as they are, but the good thing if you can do that, if you can accept like, okay, what if we cannot design? What if we cannot make a reasonable good designer for when you mix code with design? How nice can we make it if we accept that limitation, right? How nice can we make the system if we accept this limitation? And in this case, you make an item and you just mutate some values. I'll show a different way to do it as well. We do have a little bit of JSX-like syntax that you can use here. But yeah, you set the values. And then when you click an item here, you see that it clicks item number 133. Because that's then your next problem, right? Like if you have all sorts of UI items in these dynamic lists, how do you know which ID of which item is clicked? So in this case, you just say, hey, list view, do you have any items with actions? And then it gives you the item ID and the item back that has any actions inside its child structure, and therefore you can show the ID in your printf. So yeah, this is the very, very basic structure of doing dynamic data with Makepad. Let's see, where's my slides? So yeah, just to step back a little bit from the nitty-gritty of the code, also why Rust is amazing and why when you build on Rust you can do things again, is all the platforms that we can support. So you see this now running on a Mac. This is running on a Mac. But we also support iOS and Android. And I think I can show you this application in iOS. Let's load up a simulator. Open simulator. Let's see, iPhone Pro. There we go. There's an iPhone Pro. And then we can just say, hey, let's get this news feed on the iOS simulator. As you can see, it's compiling now. And it shouldn't take that long. Here we have the same application on the iOS simulator. We also have it working on Android. I'm going to see if I can show you that on a real device. iOS also works on a real device, except yeah, the iOS is very locked down, so you need to have occasional internet access to show that. So I'm going to show the Android build. Let's see if that works. Oh, right. So one of the ideas of making Makepad fun is that we support a lot of media APIs. So audio, video. We have our synthesizer. I'll show you when we can have audio output. But we also have a webcam API, so you can access cameras. The only thing is I need to name the device right. I'm going to use this one. So let's start the webcam. Just going to close a few of these. Start the webcam. I think what we have, yeah, that's me. Oh, that's intense. Let's see, FaceTime. Oh. I was expecting the webcam to show up. I don't think it feels like it. I have an idea. We'll use this one. So let's use the Android. That's actually something I could have thought up. Here's the Android phone. Let's see. Android phone. And now I have the same newsfeed. I click Android, and it's compiling. Also, remember that I did cargo clean. All of these are clean builds that you're seeing. So this is a clean build of the application to Android. So here we have it running on the Android device. And I think I also have live coding. So when you are live coding the application in the UI, you can also live code it on the device. Yeah, I need to fix something, so maybe in the second hour I can show that as well. All of the devices live code. So yeah, oh, that's enough. And also we have web. So let's see if that actually works. So now we're compiling for WebAssembly. Let's see. WebAssembly. Yeah, compiling. Also clean build. So here we have the same application in WebAssembly. And I think we should still have live coding running there as well. Let's see if I can change anything. Yeah, see? So I'm now live coding to a browser running WebAssembly with the same application in exactly the same way as I can run it here. So now we have a synchronized live coding session between an iOS simulator, a WebAssembly build, and yeah, so I thought that was pretty neat. I don't think that's useful at all, but you know, when you can, you should in this case possibly. So yeah, platforms. Finally, we can deploy to all these targets again. But just because Rust compiles there doesn't mean there is not a tremendous amount of work on the Makepad side to make it work. Like we have completely abstracted the build tooling for Android, so you can install it with a single command. Same for iOS, although with iOS you need Xcode. And a simulator is easy. A simulator, you need nothing. You can just install a simulator and run it. But on the device itself, you need to create an empty application with the right names of what you configure, because iOS works with provisioning profiles. And that is how Apple allows a developer to run an application on a device. They use provisioning profiles, and you have to generate one in Xcode. And once you generate it, it will work in Makepad Studio. But yeah. So, hold on. I'm switching so many applications now. So yeah, before you either had, you were either fast or you were multi-platform, and now you can be fast and multi-platform. And that is just a big, big change in the world of applications. So another fun example, because you know, a big reason for me to want to make Makepad is because I like making fun things with computers. This is how I got into computers. And all of a sudden a web came along and nothing was fun anymore and nothing worked. So yeah, that was a pretty dark age. So now, let's see. So, you know, all of the AI image generation is super fun, right? It's you have a computer that can all of a sudden make the most crazy picture. This was a cat axolotl, or how you pronounce that. I mean, it's amazing. Like, what you can do with it. And the only problem is the UX of the interface to the AI, I thought was really shit, especially when you have a lot of images coming in. You don't, yeah, a web browser kind of doesn't like it if you throw, I think this image directory quickly became something like 100 gigabytes or something, or 50 gigabytes of images. Web browsers don't like that much data. They really, really don't, even if it's images. So here in Makepad, you have like an image list that doesn't even use thumbnails. I just load the whole thing in there. I think there are 3K images or 4K images. I think this one is 4K. Let's see. Hold on. A macro photo, technically intricate bioluminescent alien flower. It's nice. You can ask the AI for all these things and you get these kinds of pictures. Yeah, all of a sudden I had the ability. So I wrote this application in a week. Now, of course, I also made the framework. So that is, you know, a little bit of a cheat code. But it is, for me, a benchmark of now I can slowly start to do fun things anymore. Because in that week, 80% of the time, I was still building my widgets. I was still building the UI kit. I was building the image widget that would allow you to have the right aspect ratios. I was building the text input control, which didn't have word wrapping, right? Like because we have to write everything ourselves. Yeah, every single one of these features is difficult. This is, by the way, a disco fly. I had no idea what it's a disco fly hanging out on the dance floor. It's amazing. I really enjoy playing with it now, but also because the the experience is nice. Because if you run this application outside Makepad, you can see that it has, hold on, yeah, I should make thumbnails actually, because that's better, but, so this is what you can show on your external, on your projector. So this was a thing for friends at a house party. You put this on your TV, you put this on the projector, you put this on the laptop, and then you have an actual interactive AI game. And yeah, I want this to be accessible, I want this to be doable again. And for myself, it has now become doable, and I hope that with Makepad, we can enable that for a lot of other people as well. Because if we go to, I'll show you a little bit, something that I thought was pretty neat. Is like you see that in this list, when you hover over with the mouse, the image gets slightly bigger, right? So how do you do that with shaders? Let's see. Hold on, I have to make it bigger. Image tile. By the way, every single thing you see that I do here required me to build it. So the fact that when you change the font size, your cursor tries to stay in view is actually something that you have to do. When you build your own code editors, you have to literally, every single interaction is some piece of code that you once did. So here's the shader for the image. And here you can see that I use a max scale value. So if I set it to 0.3, all of a sudden the images get a lot bigger, right? Because in shaders you can do almost anything to a pixel. You can render a 3D scene, which I don't do because it takes a lot of energy, and I'm also trying to make something that is energy efficient and runs on mobile. But yeah, you can do almost anything. Let's see where my slides are. Or did I close them again? Sorry about that. Nope. Don't want it in there. So here you see the run menu. When I select Release Studio, it runs inside Makepad Studio, as you can see. This is also nice, the startup time. But then when I click Release, this is just a normal Rust release build. So let's see where we were. Where were we? Yeah, so I think I'm about to hit the hour mark, which means that I'm going to say, let's have a short break. After the break, I'm going to go into a little bit of a deeper dive with the shaders, the shader inheritance, how I use proc macros. This is going to get very technical in Rust if you're interested, how the hot loading works. Anyway, this is just a list to see how much time we have. I also have my co-founder, Eddie, who wants to present a little bit about how he built the editor. So yeah, I think we should do that after the break.